devices and your phones. Sorry, I appreciate it. Just don't want to jeopardize your success. If we look at our question of the day, if we look at our question of the day, it says, how does the heat capacity of water affect coastal communities? So if you could get your, wow, words are hard. If you could please get out your notebook, I would greatly appreciate it. Just don't throw it. If you could please get out your notebook, I'd appreciate it. Write down that question today, and then I'll go ahead and take 10 minutes. I'm glad you're here today because we're going to take notes, and those notes are going to help you with your quiz on Friday. It's just like a 5-point quiz. Excuse me, Monday. Quiz on Monday. I apologize. Thank you. Quiz on Monday. So sorry. Jared, don't jeopardize her success.
I'm sorry to jeopardize her.
Appreciate that. All right, looking around. Dang it, has anybody seen Aileen today?
No.
Okay. I know Justin was here. Stella was here. Oh, where is he? Hey, shameless plug for Science Olympiad next year. I would love it if you would sign up for Science Olympiad next year. I think it's going to be a really good program. We just need to up our game. We just had our STEM banquet, which was a lot of fun. STEM banquet is at the end of the year. Everybody brings their families. It's like potluck. We all sign up for a dish. We had lasagna, macaroni and cheese, and key lime pie, and tres leches cake. And I mean, it was fun. And we just kind of get up and everybody, we speak about how great our kids are. We go to regionals, we try to go to a couple regionals. We only went to one regional event this year in Iowa State. Usually we go to like one in Mount Vernon also, but we didn't get a chance to do that. And then we always have our state competition in Cedar Falls at UNI. So anyway, Science Olympiad, yay. Think about it for next year. I'm gonna try to have more meetings. Well, this year we had meetings during Liberty Time. So I think it made it more approachable. And then we have like one meeting a month, I think like after school. Did we do that?
You had it like every week.
Well, towards the end,
Yeah.
more towards state, but in the beginning it was just like once a month. All right, so our question of the day, how does heat capacity of water affect coastal communities? First of all, let's talk about what is heat capacity. Turn with your pair share partners and talk about what's this thing, heat capacity. On your mark, get set, go.
So much energy material before it changes.
Sorry, Zai, your partner is gone.
I'll move there. I would not have moved.
Hey, Kendall, what do you
can
think?
talk to each other.
I think what Cole said,
All
I heard.
right,
Cole said something about like the heat and the
we got
temperature.
15 more
What
seconds.
do you think?
Well, heat capacity is how well.
Hey, Zai, what do you think?
I'm not.
Yeah, me either.
Because they have a
4, 3, 2, 1,
Justin's here, he's just not
and we
here.
are done. All right, wrap it up. Sam, turn it this way, please. Let's talk about what heat capacity is. Somebody please try to put heat capacity in your own words. What do we think heat capacity is? What is it? Heat capacity. The capacity for what? Yuma.
How much energy needs to be put in for the temperature of an object to change?
Okay, so whoa, that's not even close to how you spell that. How much heat energy goes into an object before it, can I say raises in temperature, or you want me to say changes in temperature?
I guess energy would get raised.
Okay, before it raises, should it be raises or rises? Does it matter?
Before it rises.
Before it raises in temperature 1, I'm just gonna say this, degree Celsius. Raises, it sounds weird,
It's
rises?
rises.
No, it's raises.
It's rises.
It's rises.
Don't
Before it
listen to
raises in temperature.
too. It was my friend.
Okay, that's heat capacity. So heat capacity is the ability of an object, normally like a material, like aluminum versus steel or plastic, right? PLA plastic, ABS plastic versus a rock, maybe granite or you, before it raises in temperature 1 degree Celsius. Now you are mostly water. So you got that going for you, right? It helps you not to overheat very quickly because most of what you are is water, so that, it helps your body maintain what's called homeostasis. How many of you are in biology right now? All right, so homeostasis is a word you've heard, right? Okay. Let's go ahead then, based on this, water, let's talk about it. Does water have a high heat capacity or low heat capacity? Turn with your parashare partners and talk that out.
Low.
No.
Hi.
That's right, Alex.
Low.
Water equals high heat capacity.
Give his answer.
It's got a high heat capacity because it's got the ability to absorb lots of energy before it changes in temperature. Good catch on that one. Water has a high heat capacity. It can absorb high amounts of energy and stay pretty maintained, which is also why in those older houses we had hot water heater, heaters around the house. Does anybody have those old hot water heaters? They're like cast iron filled with water. No,
I think that's just you.
no, I don't have that. My
I have
sister
one in
has
my
an old
old
house. She has an old house in Vermont that has that. All right, so water has a high heat capacity. Great. Now, how does this then affect the coastal communities? Turn and talk that out. Ready, set, wait, not yet. Okay, ready, set, go. Why then?
Oh.
That's what I was gonna say.
Yeah, that's exactly what was going through my brain.
That's what I wrote down. That is not what she put.
Oh,
It's the best class.
Do I get a
Alright.
prize for that?
You get a prize for, yes, you're gonna do really well on the quiz.
You get a cookie?
I do.
She said we're the best class.
You really?
Cookies?
She said we're the
Water
best
has a
class,
high
so I
heat
should
capacity. Shh. So then how does this affect coastal communities?
Can I have a cookie?
Sam?
Water holds the temperature a lot more than just straight land, and it keeps the temperature around the same.
Okay, so water helps to regulate, is what you're saying, keeps the temperature the same. To regulate, okay, keep same. Water helps to regulate the temperature of cities on the coast. Picture it. Sicily, picture it. So you are New York City, and, well, let's go San Francisco. You're San Francisco, and it's really hot, but the water temperature is a cool current, and so the air blowing over that is going to absorb the energy from the air, so it's gonna bring cool currents to you. Picture it. The land is cold, but the air flowing over the current is going to absorb energy from that current and bring warmer temperatures to the land. So that water kind of, are you bringing me a cupcake?
Yeah.
Yes! Liz, thank you. I appreciate it very much.
So we do get treats.
I do.
Where's my cookie?
You're not getting one. That is adorable. Is this a mushroom on the top?
Yeah.
I love it. That is so cute. Thank you.
I should have skipped.
Why do you get a cupcake?
Because I guess they like me.
So you're saying they don't like us?
Yeah.
Do you want the person to bring like cupcakes for all 30 of you?
Yeah.
Duh.
Oh, well, I want that, but I know
Not
that.
me, I don't
Yeah,
have
that's
any.
kind of hard.
Yeah.
All right. Let's go ahead and look at what we're doing today. Oops, sorry, that has been changed. We are not going over elevation. I apologize. We have changed it to do, we're doing notes on climate factors today. So today, our content objective is still going to remain the same as we have. We're still looking at how some factors work together to determine a regional's climate. What's up, bud? Yeah, go quick, because we're gonna start notes. I don't want you to miss any of it. Students today are gonna write notes on different factors that influence a region's average temperature and precipitation. And I'm gonna tell you a little hint for the quiz on Monday. There are two main factors, Jaren, pull out your phone, that influence an area's climate. Rebecca and Nikayla, get your heads off the desk. You cannot sleep in my class. There are two main factors that influence an area's, yes. You
Can I go to the bathroom?
Or
I
you
was just gonna
can't stay
ask.
for sleep. You can't stay for sleep.
Can I go
As
to the
soon
bathroom?
as he comes back, you can go.
And then you can go after
Hey,
me.
stop! There are two main factors that influence an area's climate. One is temperature and one is precipitation. Today, the notes we're gonna look at are going to help us figure out what then are the variables that can change an area's temperature and what are the variables that can change an area's precipitation. So if you could please first, let's get out our ocean information that we looked at yesterday so that we can kind of quickly go over that from yesterday. That would be great, so we can make sure that we're all on the same page. The last thing we did together was we located the equator on the map, and we said water near these low latitudes is warmer than water near the high latitudes. Why is that? We said that that area receives more direct energy from the sun. So the equator receives the most direct energy from the sun. That's where we're at. Then it says find letter A on the map. This represents the country of Japan. Country of Japan has a temperate climate. Changes between summer and winter in this country are generally relatively moderate. Why do we think that is? And what are we looking at here? Japan is an island surrounded by large bodies of water, which help regulate that land. Okay, so that's why. Water has a high heat capacity. It is surrounded by water, and so it helps, that water helps regulate the land. Not too hot, not too cold. Then the next question was looking for, it says now, find letter B on the map. This represents the area of Northern California. The average temperatures off the coast at this location would be 55 degrees Fahrenheit. So if Cullen took a dip into the Pacific Ocean, it would be rather cold, 55 degrees Fahrenheit. But then if Cullen got in an airplane and went over to Japan, which is the same latitude, he would be swimming in 70-degree Fahrenheit water. So why is it these two countries, these two areas, have different temperatures in the water if they are at generally the same latitude? So we're looking at this area right here, right? Why is it that this one is going to be 70 degrees and this one is going to be 55 degrees? So go ahead and turn that out with your pair share partner. What do we think? Hint, look where the water's coming from. On your marks, get set, go.
Western California is being hit by colder water
The
from
water's
the
coming
northern
from
part of the Pacific
south,
Ocean
the
and
west,
the
east, one of those four, okay?
and
Some direction.
water from
Jaron, which city are you talking about right now? Are you talking about location B or A?
A,
Okay, A. So A's water is coming from which?
West.
Okay, but also,
north,
look honey, this is,
East.
okay, how about this? North, south, west, east. Okay.
east, come from the east,
Okay, but it's also coming up from the
south,
south, and it is warmer or colder down here.
it's warmer.
Right, so it is coming from a location where this water is closer to the equator, so it's gonna have more direct sunlight that's going to be absorbing in it. It's warm, and then this water brings that energy right up to Japan. Now, this is coming from the
North,
north, and that water is
freezing cold.
cooler, right? So we've got cooler water up here, not as much energy, and so it is bringing less energy to the coast here, and we can see that in the temperature. By the time then that it comes down here, it's a slow moving current. It's gonna absorb lots of energy from the sun and then bring that energy up. If we look at the very last question on the page, it says, how does ocean currents help regulate temperatures? Well, it's really good at like moving energy around the globe, yeah. And so ocean currents are good at moving energy around the globe.
Thank you.
How's that sound? Fantastic. Let's go ahead then and take some notes because I want you to be prepared. You cannot use these notes on the quiz on Monday, but I want to have you have them, that's weird, over the weekend so that I know some of you are gonna wanna go ahead and study. At least that's my hope. All right, so these are the notes we're looking at. One side is gonna tell you everything you need to know about changing an area's temperature. The other side is gonna tell you everything you need to know about changing an area's precipitation. And what did we say precipitation was? Claire, this was for you. What is precipitation? Rain, snow, something coming out of the atmosphere. Thanks, Claire, you're the best. Is that the first time I've ever called on you in my class? It's very cute. Claire, we gotta like get you more involved. All right, I don't know why that's not shutting off. Is it too dark?
No.
Great. Perfect even. All right. So what we're gonna do, I didn't do this my last class, but I think what we're gonna do with this class is we're gonna try to run through the slideshow, and you should be able to fill in the spots that you see on the slideshow. If you are confused, let me know. But we've got two little, I don't know, what would these be?
I can't see it.
Squirrels.
Gophers, squirrels, there's something.
Beaver.
I'm not really sure what they are, but there's
Bigfoot.
something. And we can see that they're two, okay, cats, they're two totally different climates, right? One of them, we know there's two different climates because this is a very moist environment and this one is very dry. And so we're really pushing this idea that climate can be run by, hey man, temperature and precipitation, absolutely 100%. All right, so the factors that impact temperature, the first one, latitude, write that down in number 1. Do you see number 1 on your paper?
Yeah.
Latitude. That's the first thing that affects an area's climate. George, write this down, man. Number 1, latitude. So this is the Earth. Can you see that circle that I gave you? That's supposed to be the Earth. There's a line in the circle. Could you please write the word equator on it? Write the word equator in the middle of your sphere. So that's our equator. All right. Now, we have to make sure that we add our sun. The sun's light hitting the Earth, right? And where is it going to get the most? Oh, okay, let's go up here. We've got our different zones. We got polar at the top, temperate in the middle, and equator, we've got our tropical. And then it's a direct mirror image down below. So we've got tropical, and then we'd have temperate, and then we'd have polar. Why is tropical so warm?
It's closer to the sun.
Okay,
It's the equator.
it's not actually closer to the sun. We gotta stop saying that.
It's
I've heard
closer to
so
the
many different
equator.
people say that. It's getting the most direct sunlight. Yes. Yeah, it's getting the most direct sunlight. So the tropical, and if you can write maybe on that line, like most direct, well, here. Latitude changes temperature because it changes the intensity of the light. Fill that in your little box. Latitude changes temperature because different latitudes get different intensities of light, if you want to say that. Different intensities of light. The equator gets the most energy, right? So I'm going to write somewhere on here, most E, most energy. Okay, up here, it's got less E, less energy. And what that means is this is going to be very warm, and then up here is cold, down here is cold. So as we go south from the equator or north from the equator, this is what happens. If you want to add that to yours, add it to yours so that it makes more sense to you. But that's the gist. Less energy, most energy. Sound good?
Yeah.
So it's the latitude, meaning these are latitude lines. The further down you go, because of the angle of the globe, right? It's a sphere, it's not a flat box. It's not going to all get the same shape. It's going to have 90-degree angle, and then where angle kind of changes. Let me see if I can show that for you. So this would be like a 90-degree angle. It comes in and it hits. This then, we've got an angle of light, and then this is even more angled light, which is going to change the intensity of the light. And we're going to look at that more when we get to our seasons lab on Monday and Tuesday. All right, fabulous. Let's move on. All right, the second thing, is elevation. So if we could write that down, that would be great. I'll get rid of all of these extra writings. Unfortunately. Okay. So elevation, another word for elevation would be altitude. And Mount Kilimanjaro, let's bring Mount Kilimanjaro up there. Mount Kilimanjaro is on the African equator. So it is getting direct sunlight. It's on the equator. Yet, what's at the top of Mount Kilimanjaro?
Snow.
Snow? What? That's crazy. There shouldn't be snow at the top. It's at the middle of the equator. So it must not just be, right, about latitude. There are other factors. So what I want you to do is I want you to say that imagine it's 90 degrees Fahrenheit at the bottom, or sea level. Do you see the little line there?
Yeah.
And let's say that it's about 20 degrees Fahrenheit at the top. And you don't have to write that there's snow there if you know that that's snow, fine. All right. So then who cares? What's the big deal? Well, as you go up the mountain, what happens to the temperature?
It's cooler.
Yes. Increase in elevation equals a decrease in temperature. But why, Mrs. McGrain? Why? Glad you asked. It's all about air particles. Where do you think the most air particles are? At the bottom of? Yes, let's draw some of those in. It's all about the air. Air. So imagine that these are little air particles. Has anybody ever seen those National Geographic or something where people climb the mountain and by the time they get to the top of the mountain, what do they have on their face? Oxygen. Why? Because there's less air up there. There's less air up at the top of the mountain. Well, guess what? The sun gets absorbed by each one of those molecules of air. And so then it radiates back out, that energy, and it keeps us nice and warm down at sea level. But the higher up we go, there's less air, there's less stuff to absorb the energy of the sun and re-radiate it back out. So it's cold up there. Shocking. Elevation changes the temperature because the air gets thinner so it doesn't hold as much heat. It seems like it should be more complicated, right? But it's kind of basic physics stuff. More air molecules, more stuff, individual pieces for that sun's energy to be absorbed into and held onto. Fantastic. Sound good?
Yeah.
Am I going too quickly?
No.
For Jared. Anybody else? Or Jared? Anybody else? Get off your phone. You're jeopardizing your success. Gosh.
You should start taking them.
I don't want to. I just want to say get off your phone.
Yeah, but
You're high school students, right? Monitor yourself as best as can. All right. Here's an example of that. I love this example because what it's showing, and we have to kind of look at what we're seeing here. We've got temperature in Celsius over here, and we've got January, February, March, April, May. So these are the months of the year down here. All right. I'm not really necessarily worried about precipitation right now. I just want us to focus on temperature. Let's look at the temperatures of two different places. We've got, this is the United States, and here is the dot that shows us Phoenix, Arizona. And the latitude of Phoenix, Arizona is 33 degrees latitude. They're both basically the same, 35 latitude. But look at the elevation. Hi, Carolyn. So the elevation of Phoenix is 338 meters. The elevation of Flagstaff is 2,134 meters. Which one's higher up the mountain? Okay, one more time.
Arizona.
second one.
Here's this one, Phoenix. Here's Flagstaff. Which one's
Flagstaff.
higher up the mountain?
Flagstaff.
Flagstaff is higher up the mountain. Let's look at the temperature range. This is Flagstaff. This is Phoenix. Which one has higher average temperatures throughout the year?
Phoenix.
Phoenix, because it is at a lower elevation. This one has cooler temperatures throughout the year because it is at a higher elevation. ta-da, data to back up what I said, so you know I'm at full crap. Good? So the higher up the mountain, the colder it will be. The higher up the mountain, da-da-da-da-da-da. Oops, sorry. The colder it will be, the colder it will be. All right, let's go ahead and look at factor 3 that affects an area's temperature, and that's ocean currents. Hi, are you okay? We're taking notes, and I've posted this Google slide on Canvas, and we are recording it as we speak. Right, Sam? Sam says yes. All right, let's go ahead and look at it. It says water temperature can change, water can change air temperature. Think about you blowing over soup. Warm ocean currents will make warm air flowing over it. The air will absorb the energy from the ocean currents. Does that make sense? Just like if you put your hand over hot soup, the air will feel warm. That's what's going to happen as warm air is flowing over warm ocean currents. That makes sense?
Mhm.
Cold ocean currents will have cold air because any energy that was in the air will be absorbed by that ocean. Energy always goes from high to low. Okay, high areas of energy to low areas of energy. So if the water is warmer than the air, energy will go into the air. If the air is warmer than the water, the energy will go out of the air into the water. All right, this then changes the land's temperature. How? Warm air makes the land warmer. Cooler air makes the land colder. That makes sense, doesn't it?
Yeah.
Yes. Let's draw a picture. This is South America. South America is very special because it's got two different currents flowing on either side of the continent. It's got a warm current flowing on the, would this be east side? This is the east side of South America. And so we've got a warm current coming down on this side, and the air flowing over it then becomes warm, and that makes the land warm. Okay, so if you want, you have a picture, you can go ahead and if you want, draw like, warm water if you want, or a warm current, and then air going over it, and this side of the land is going to be warm. On the other side, you have got a cold current coming up this way. And so the air blowing over that, the mass of air then becomes cooler, and that means this side of the land is colder compared to that side of the land. So if you want, you can write like warm over on this side, you can write cooler over on this side, you can put like, air, if you want on your little pictures. Or not. Don't do anything, but the more you write down, the easier it'll be for you on the exam. My husband's been out of town, and I just have my puppy all to myself, and it has been so lovely.
That's awesome.
It has been
You
great.
don't miss him?
Dude, I was
Of course I miss him. He's only been gone one day, and he's coming back today. He went up to help his dad with his taxes.
Oh, that's sweet.
Yep. That's what we do with our parents as they get older. I want to show you the ocean current. So this is that Brazil current that is coming down. Notice it's coming from the equator. So it's coming on down this side of South America called the Brazil current. We've got the Peru current coming up from a lower a higher latitude south, though it's cold by the poles, and it's coming up the Peru current on this side of South America. So we're going to have a colder temperatures over here and warmer temperatures over there. So if you're going to South America on vacation, you might want to vacation on this side of the continent if you're going to the beach. I'm not saying it wouldn't be beautiful, but let's just go to beautiful beaches with warm ocean currents. Just saying. You're welcome. All right. Don't jeopardize your success, Jared.
I apologize.
The fourth thing is large bodies of water. Write that down. Large body of H2O, or,
So large is the H.
did I really?
No, I didn't.
Oh. So large bodies of water reduce extremes, or you could say regulate climate. I don't care what you say. Extremes mean way hot, way cold. It kind of levels everything out. All right. Does this look like the picture you have? Okay. So then the only thing you're missing on your picture is air. So you might want to draw yourself an arrow and label it air. Going over the Pacific Ocean. Okay. So then we're going to fill in some of the words there on the right-hand side. Thank you. So water has a higher heat capacity compared to land. This goes right to our daily question that we started with. You okay, Cole? This means water heats and cools much more slowly because it's really good at absorbing energy and holding on to it. Because of this, water can impact the land's temperature. Warmer ocean water means warmer air in the winter. So that means if it's winter time and it should be cold, right? That air flowing over is going to take, like if this is 60-degree temperature and the continent should be in the middle of winter, let's say it should be 50s, this is going to put energy into the air and warm up the land. However, if, climates are then made warmer in the winter and cooler in the summer. So it's the opposite in the winter time. If it's winter time, and the air is cold, it's going to warm up from the ocean because the ocean is going to be pretty consistent as the land changes. This works really well in New York City too. New York City is unseasonably warm in the winter time, but that's because it's right there on the ocean. Anybody been to New York City? It's gorgeous, dirty. I found it dirty, but beautiful. Okay, so air moderates temperatures. I don't care if you put that there or not. If you want to, I think there's room, but air moderates or regulates temperatures. Because of the energy, right, that it is absorbing or putting into the water. It's not the air itself, it's the water that the air is moving over. All right, so let's tie in our heating versus cooling lab. The sand should both heat and cool faster than the water. Did we see that in our lab?
Yeah.
Yes, we did, because water has a higher specific heat capacity than sand, meaning that it takes a lot of heat or energy into the water in order to raise the temperature of water just by 1 degree Celsius. The high specific heat capacity of water also explains why it cools slower. More energy must be removed from the water in order to lower the temperature by 1 degree. Has anyone ever been swimming at night?
Yeah.
Oh, it's the best.
So nice.
It's so nice, except for the mosquitoes.
Yep.
It's so nice because the air temperature is really cool, but the water holds on to that heat energy, and you just feel so lovely and warm in the water. All right. When I get my swimming pool, y'all can come over.
Bad.
Yeah, I'm on like a 5-year plan. We got the puppy, which means we had to get a fence. And now it's like I'm just waiting to, manipulate my husband into getting me a swimming pool. In a nice, loving way. Factors that impact precipitation. Let's go ahead and look at that. All right, the first one is going to be what's called prevailing winds. These are those large air masses that move around our globe. Remember when we were talking about continental, tropical air masses and continental polar air masses? Those are large prevailing winds. Okay, so this is the continent of?
South America.
No, honey.
South Africa.
It's Africa.
Just
That's okay. So we have some green and some brown colors on this. What does the green mean?
Land. High heat.
It does, yep, grass, okay, so it's got lots of vegetation, so we've got areas of vegetation, and these brown areas are areas where
Mud.
there's no vegetation, okay?
Sand.
Yeah,
Mud.
in particular,
That's a
there's
big
lots of sand
desert.
here, what do we
It's a
have
desert.
here? Does anybody know what this is?
This is the
Desert.
Savannah
The
Desert.
Sahara Desert. We're gonna talk about why the Sahara Desert is there. Okay, so air masses that are moved by wind over land are very dry. An example of that would be the Sahara Desert. And I'm gonna go ahead and, dang it, I wish that it would have, it'll show an arrow in a minute. So the Sahara Desert is an example, and that's because we've got a large mass of air coming down from Eurasia. It has been traveling over land, so it is super dry. It's not been able to go over ocean to absorb any moisture. So any time that there is moisture, like if there was any little moisture here, this air is so dry, it's gonna wanna absorb it like a sponge and carry it away, keeping that land dry. Air masses moved by wind over water are going to be wet or moist. The example here would be the coastal tropics. And that would be this green area in here are the coastal tropics. Like the Congo. All right, so we've got this large mass of air. If you want to go ahead and write yourself an arrow coming down here, and this is going to be dry. It's dry air, and so it's not carrying any moisture to this area, and any moisture that is in this area, it's going to pick up and carry it away. This is going to be a wet amount of air because this is what would be like maritime tropical, and it's going to be moving over the water, depositing that moisture into this area. Sound good? So prevailing winds would just be like big, massive amounts of air. And again, if you want to remind yourself what that is, it's something like, oops, I can't do that. It would be something like continental, like this would be maritime tropical. If you just want to remind yourself. Right, that's what a prevailing wind is, just a big mass of air traveling over different parts. Okay? Okay. Again, we have what continent, Jaron?
Africa.
There you go, it's Africa. And we're gonna look at latitude and ocean currents, how ocean currents change with latitude. So write that down. Okay, now we need to think about if air is warm or cold, what's it gonna do with the temperature? So warmer air holds more water. There's more energy in warmer air. I really want us to write that. Do you have space above here to?
No.
You have space next to it.
I need a little.
I'm just gonna say more E for more energy. Warmer air has more energy, and you need energy to evaporate moisture and hold it into the air. Okay. Cooler air holds less water. There's less energy to evaporate, so you're gonna have drier air, even though it's flowing over water. Cold ocean currents cool the air so it holds little water, which causes little to no precipitation. So now we're saying it's not just about having an ocean current, we have to see if it's a warm ocean current or a cool ocean current. Cool ocean currents, less energy, less water. An example of that would be this cool current coming up through here. And notice that there's a little tiny desert at the bottom at the Horn of Africa. So yeah, because it's got the air is going over a cool current, which means there's very little moisture in that air to deliver to that area. I think, yep, we actually have it as the Namib Desert, but yes, I think you're right, it's the whatever you said. Kalahari Desert.
Yeah.
Yeah, but you can see the Namib Desert right there on the coast too.
Oh, okay, yeah.
Yep. I thought you knew that out of your head, but
Oh,
I
no.
see that it's down like, dang, I want you on Science Olympiad next year. He didn't even know it's Africa, but he does now know it's Africa. You know, and I mean, it does kind of look like South America, sort of.
No, it does.
Okay.
Compared to pictures.
Right,
If
absolutely,
you-
yeah, except it doesn't, but,
If
Maybe.
you haven't looked
In
at a
my
lot
brain
of
it
globes
does.
or maps.
right, absolutely, 100%, thanks, way to pick them up. All right, and again, here's that ocean current. So we can see that we've got this Benguela cold ocean current coming up right here. So if we had air flowing over here, that air would be cool. There wouldn't be a lot of moisture. By the time it gets up here around the south equatorial current, this then warms up, so air coming over here is gonna be warmer and it's going to drop. We're gonna get lots of rain here, but this is going to be very dry. So again, you gotta look, not just is the air going over water, but is it warm water or cold water? Cold water, less energy. Less water. All right. Now let's talk about some mountain barriers. I'll get this out of the way, I apologize. We're gonna pretend that that is me at the top of the mountain, because I want to. All right, I wanna talk about a mountain barrier. And when I say mountain barrier, I mean this is a mountain range, and this mountain, the air cannot go around the mountain, so when the air approaches the mountain, the only way where the air can go is up the mountain, okay? And what did we learn about temperatures the higher up the mountain we go?
They get
The cooler it will be, the cooler it will be. All right, now, there are two sides of the mountain. One is the windward side, one is the leeward side. Please write that on the sides of the mountain. On the exam, you will have a question that says, what side is the windward side of the mountain? Please do not tell me it is the left side of the mountain. The windward side is just the side of the mountain that the wind approaches. Does that make sense? Windward, wind side. It could be that the wind is approaching from this side of the mountain. That means this would be the windward side of the mountain. But for what we're looking at today, I had to pick one. So this is the side of the mountain that the wind is approaching. Does that sound right? But don't always think that the left side of a mountain is always going to be windward. All right. Mountain forces air up and it cools it. We said that. The higher up the mountain, the lower the temperatures.
Huh? What is it?
Mountain forces air up,
Oh, now I see it.
okay, and cools it, meaning less energy. Okay, so we have, I'll just say less E, less energy. Okay, so it cannot hold the water in a gas state. It condenses out and it goes on the side of the mountain. Let's imagine that the mountain down here, let's say is 90 degrees. Can we write that? And then at the top, let's just say it's something like, shoot, I don't know, 30 degrees. At the top of the mountain, it's 30 degrees. Okay. So the air is full of water at the bottom. So do me a favor and draw an arrow that goes up, and we'll just say that it's wet air. Wet air. So it's got lots of water in it at that point because it's got lots of energy, and so it's filled with moisture. Okay. We good so far?
Yep.
Now, the higher up we go, it cools. Okay, so then it's cooling off, it's got less energy, and so it all dumps out. And you can make yourself, you know, this and just kind of like showing that snow is falling on this side of the mountain. It can no longer hold the moisture in a gas state. It condenses out, and on this side of the mountain, on the windward side, it's going to be lush and green and tropical. By the time the air then goes up the mountain and then on the other side, what's its moisture content? Dry. So now cool, dry air, or cool air that is now dry, sinks down the mountain and produces deserts. We say this side of the mountain is in a rain shadow. The rain can't get to that side. An example is Death Valley. Okay, so on this side, now we have, let's see what it says. No, back up. So now it is dry, cold air. Now, by the time it gets down here again, it's 90 degrees. It's gonna heat up in temperature, and anything that has moisture on the ground, this dry air is gonna wanna absorb and then carry away. So it just constantly dries the land on that side of the mountain. We're running out of
You have
time.
like 2 minutes left.
Damn it. We can do this. All that Jimmy Jack and we were doing. Okay, there's a good picture. Okay, this is the last one we have. Lake effect snow. Let's do it. What I want you to know is this is ice, and this is an area like Buffalo, New York. So you have land that's 0 degrees Fahrenheit, and then on this side is 0 degrees Fahrenheit. It's a lake that's so big, it can't freeze solid in the middle. So comparatively speaking, this open water is warmer than the land on either side. Are you with me?
Yeah.
Air blows over land and ice. Ice hits water in the middle. Do you see where we are here? Oh, wait. Sorry, here it is. Okay, so air blows over land and ice. It's cold and dry air. We gotta fix this. Hits water in the middle of the lake, and it warms up because the water is warmer and soaks up water. You could just say warms up, soaks up water. When the air then hits the other side of the land, it's going to cool off, and what's going to happen to the moisture?
It's gonna
It's going to dump it. Air hits the land on the other side, cools and dumps water as snow. This is all jacked up. I got to fix this. So examples would be like Buffalo, New York. So over here, it's been traveling over land. It's a prevailing wind, cold and dry. It hits this part in the middle. Warm, humid air picks it up, comes over here, cools off, and dumps it all on this side. These are clouds that air has passed over. Look at the shape of the clouds. The shape of the clouds that the moisture has picked up is exactly the shape of the lakes that just passed over.